Hello. In this video, we're going to take a really quick look at how to add vectors graphically. Now, graphical addition does work for vectors. However, when you are looking at graphical addition for vectors, please note that this tends to be tricky to do because it's really difficult to get your scale diagram exactly right and to draw using your protractor exactly right. So what we're going to do is we're going to take a look at what adding vectors means. So in this case, I've got two vectors here. I've got the vector A, which is 3, 1, and I've got the vector B, which is 2, -2. If I draw those vectors out on my coordinate plane like this, I've got vector A here, and I've got vector B here. Notice these vectors are both starting at the origin. One thing to note for vectors is vectors do not care about their start point, they just care about their direction, how far they go and in what direction, their magnitude and direction. If I want to add these vectors together, I need A plus B. What that means is I'm going to go A, so I'm going to go 3, 1, and then I'm going to go B, I'm going to go 2 and -2. A way that I can draw this is if I start with A, so I draw vector A, and then starting at the end of vector A, I draw vector B. So vector B is +2 on the x-axis and then -2 on the y-axis. So I can actually draw vector B right here, like that. So there's my vector B at the end of vector A. You may notice what this means is that my resultant vector, in this case vector S is what I'm looking for. My resultant vector is going to go from the starting point to the ending point. So my vector S is going to look like this. And that is going to be S there. So if I, pretty straightforward, look at this, my vector S in component notation would be 1, 2, 3, 4, 5, and -1. 5, -1, like that. So there's the graphical addition. One extra thing to note is that for addition, it doesn't care about the order. I can do A plus B, or I could do B, and then if I add A on here, it's 1, 2, 3, and +1. So my A vector here would end up getting me to the same location. So going A and then B, or going B and then A, gets me to the same resultant location here. And this is a good way to check to make sure you did it right, because that should end up with both getting to the same place. And we actually call this here the parallelogram method. We can make a parallelogram with the vectors and end up getting our resultant is the diagonal of that parallelogram. Alrighty, hope this video has been helpful. Have a great day, and I'll see you in the next video.